Okay, so let's do one more example of verifying trigonometric identities. I'm trying to show that this big expression on the left is going to equal this expression on the right. Okay? All right, so I'm going to work with this more complicated expression. Remember the tip in class? It's harder to pick the simpler one and make it look like the complicated one. Because if I pick the simpler one, I now have to add things into it to make it look like this large one. And that's more difficult to do. It's easier to take a large, more complicated expression, use the fundamental identities, and take things out of it to make it look like the simpler. Okay? Now, another tip we had in class was look to the future. If I'm going to make this expression try to look like that, I notice that I have two terms on the left, one added with the second, and I have to add them into one to make it look like this. Okay, so one term, two terms. So that already hints to me that I need to add them. So 1 plus cosine x times sine. Okay. Now, what would you need to multiply this fraction by in order to make its denominator look like this? Okay. It's already got 1 plus cosine, so it needs sine. Okay. But anytime you're working with fractions, you have to balance them top and bottom. Okay. So this is sine over sine, which is equal to 1. And now these two will multiply to give me sine squared x. Okay. This denominator has the sine, but it's missing the 1 plus cosine. Okay, so let's be careful there, the way I wrote it. It should be that 1 plus cosine multiplied by this entire expression, 1 plus cosine. Okay. Now we need to multiply these here, and so it's a binomial times a binomial, so we need our favorite four-letter F word, and that is FOIL, right? FOIL you. Okay, so now front step is 1, the outside step is cosine, and the inner step is cosine, so I'm going to get 2 cosine x. Last step of FOIL is cosine squared x. Okay, so I think we're on the right track. I see that these two here, these two terms, will add up to 1 from the Pythagorean identity, right? So now these two are adding up to 1, so that's 1 plus 1 gives us 2. 2 plus 2 cosine x. All of that divided by 1 plus cosine, divided by sine. Okay? And we're on the right track, because I know if I want a cosecant, I know that it has a sine in it. If I rewrite that cosecant, then that's the same as 1 over sine, okay, which is the same as 2 over sine x. Okay? So I can now see that I can get some cancellation here, and that will occur if I factor. If I factor out a 2, okay, those 1 plus cosines will cancel, and there we have it. Okay, I now have 2 divided by sine of x. Okay, and that's exactly what we have there on the right-hand side. And we are done. All right, so we have proven that this original left-hand side, this expression, is now equal to this right-hand expression. Okay? Really, we did it through, again, the transitive property. We showed that this expression is equal to a third, okay? And so this expression here is equal to this third expression, and therefore these two are equal. All right, that's it.